So welcome back. This is now day 3, correct? If I'm wrong. Good. And you had an introduction to Git. I hope you got something out of that. It's hard. It's overwhelming. But Josh is right. We use Git, but we really use like this much of the functionality of it. It's just basically like you use it for like a place like you have the remote repository and you can store your code and you use the versioning so that you make changes and you can always back up, which is just amazing. I actually just had that with a package I'm writing where I introduced a bug somewhere, I didn't realize it, and then I had like other commits, and so like things were working before, and then they broke at some point, and I didn't know where. But with versioning, you can go back and say, okay, let's install this commit as a package. Okay, the bug is not there. Let's install this one, the bug is there. And I just kind of like, spoiler method my way through to get to the place where the error was. And so, yeah, it's without that, I'd have been blind. I just would have had to like track down and debug this enormous package for, yeah, like that. So, yeah. So I encourage you to explore it and to use it as much as you can. If for no other reason, all interns and students that I work with, I make them have a Git repo. And, when they ask me to like look at their code or something, I'll be like, okay, well, I can just pull from your repository, right? Because it's all up to date, right? And often it's not, but it's sort of like see, this is another way we use these repositories is that if you want me to look at your code, you don't email me scripts. I download them. I've got a clone, and I pull, and I get the latest version. So I can rant about Git all day, and I should probably stop. Today we're going to talk about. I had said, and I think I took it out of the schedule that I wasn't going to do tidyr, which is the package where you have a bunch of messy data and you have to kind of fix it so that it looks like something you can analyze. We're going to do that because I decided that all of you, because the reason I had taken it out was because it's a little complicated for beginners, but most of you aren't true beginners. So I think we can do this, and hopefully it'll be the exercises will be a little bit more challenging than the ones that you did with the introductory stuff. So, all right, so I'm going to walk everybody through this. People on Zoom, wake up if you're sleeping. We're going to go to the DCC on demand. We're going to go into interactive apps. Probably most of you are there already, but I'm going to go through it anyway, just in case. We're going to click on CHSI RStudio Workshop. The screen should be on, and if I plugged it in, it would be. How about that? Sorry, guys. Oh. Okay, one of these works and one of them doesn't. I don't remember which now, of course. So remember that it's not instantaneous. Is this the one that doesn't work, maybe? Yeah, I'm gonna go with that's the one that doesn't. Oh, it went. Okay. Yeah, I don't. What are they doing? Are the electrons just like strolling? Like, okay.
They're union electrons.
They're union electrons. Okay. All right. Okay. So, sorry. Now I gotta go back and start again. So, I'll just start completely. Okay. Let's click on web browser. Okay. So we're gonna go to DCC on demand. And log in if you have to. And then interactive apps, CHSI RStudio Workshop. And then grab yourself 4 wall hours and just leave all these settings as they are and launch. Okay, and then we'll wait, and everybody's doing it now, so now we have to wait for the little blue box to come up. Okay. And connecting. Okay, so, oh, so you guys just did Git, right? You are probably in another project right now. Good. I'm glad I remembered that. It only took me 6 years. Alright, so go to the File menu and go to Open Project and go to the 2023-2024 HIV workshop, and then go to the HIV workshop.r project and click on that file. Okay. And I'm gonna just go ahead and knit this and work off the HTML until we get to the exercises, or maybe at least until I get to starting to run some code, but there are some figures in here and stuff that I want you to see. Okay, so, tidy data. So we're gonna learn what tidy data is, and then we're gonna learn how to take data that is not tidy and make it into tidy format. And I also figured, and part of that is also joining tables together. And I realized that's actually probably something, at least definitely you, because you're working with multiple databases, right? I don't remember your name. What's your name?
Elizabeth.
Elizabeth, aren't you working with many data sets for HIV? Or was that somebody else?
That is the goal.
Yeah, that's the goal. Okay, right, yeah. So like things like manipulating, these are probably things you are gonna really need. Yeah, so anybody who's going to have to manipulate a bunch of data, or even like one messy Excel spreadsheet is going to do this. Okay, so in R, there's something called the tidyverse. Most of you have heard of it. And I don't know, most of you probably know, but I'll say it anyway. Tidyverse isn't one package. It's a whole bunch of packages that were developed around the same time with sort of a, like, let's modernize this language that started in like the 60s and kind of just got passed along, and fixed a lot of just annoying things, not problems, but annoyances with data frames and how they work and stuff like that. And also things that people were doing a lot in R, like using like base R. They coded into these little packages for that have like basically wrappers for code that people were doing. You know, people were writing the same chunks of code over and over and over again, and they were like, well, why don't we put this in a package? So they did. And so tidyr is one of the packages. dplyr is another. So tidyr is the one that takes messy data and makes it tidy, and then dplyr is manipulating data frames once you have them in tidy format. And then ggplot on top of that is going to take your tidy data and make you really nice plots. And there are other like packages for making nice tables and things like that. But the first thing you have to do is you have to have your data in tidy format before you can use any of these nice tools. And one of the discoveries, I thought it was really funny when in Hadley Wicked's book, he said, when I or we discovered the pipe. This is an operator. Can you see this? Maybe bigger. So here, it's percent greater than sign and another percent. This sort of syntax, this percent something in the middle percent, that's how you make a binary operator in R. And a binary operator is one that has, you know, it takes two arguments, and it's in, it takes them one argument to operate on, like plus, for example. Plus is a binary operator. And so this works like that. So, and it's a pipe. When I call it a pipe, I want you to think about actual pipe with water running through it. Because what it does is it takes input from the left-hand side and it flows along the arrow, puts the output into the next function. So this iris is a data set that's used for practicing in R, and it's one of the most used ones. You'll find examples on all over the internet. And again, when you just type the name of a variable in R, it prints that. So this is printing the iris data frame, and then putting it into the function head. So sending the data frame into the function head, with n equals 10, so it takes the first 10 lines of that. And what you end up doing in tidyverse is building up these pipelines where you start with a data frame, and maybe you select out some columns, and maybe you filter out some rows, and then you might do some group by, and we'll go into all of that, you know. But you'll see these long flowing pipes, and it's nice, especially if you're from a country that reads from left to right. It's intuitive for you. And when I laugh about the discovery, Unix has a pipe operator, and they've had it since the 50s. And it's the bar, the vertical bar on your keyboard. Like, you probably never use that for anything. Well, it's also used in logicals, but yeah, so the pipe's been around for a really long time, but they finally realized that, oh, we can use this and make our code read better. But one thing that does happen with these, and I'll show you as we go along, it kind of buries the intermediate steps. So if you're reading somebody else's code, or worse, your code from 6 months ago, and you're like, what am I doing here? It lumps everything together, and it's sometimes hard to read through what you did. And so what you can do is, I'll show you, you just execute like piece by piece, so you can see the intermediate output. So this is just showing you there's another, you can use sample n, size equal 3. So now I've just got 3 random rows that I'm choosing out of here. And this is a hooky example. I think there's actually a different way to do this. I think you can use poll. But I'm taking the data frame, I'm sampling 10 rows, and then I'm pulling out the petal with column. The reason you see the funky syntax is because what I really want to do is I want to pass it to the mean function, and the mean function only takes vectors. And if I use like a select or something, which we'll learn later, to pull out this column and try to pass it to mean, it won't work because it's still a tibble. And that's one of the things that we find in tidyr, is it tries to preserve the data structure that you started with. So in sort of ordinary R, when people selected columns using the $sign, you had this thing called a data frame, and then you pulled out a column. Now it's a vector, right? And you have to kind of know what you're going to end up with, and sometimes you could end up with things that you weren't data types that you didn't mean to create because you weren't, because in some cases an operator would return a vector. In other cases, it would preserve the data frame structure, and it was very confusing. So in tidyverse, you'll see that the tibble is mostly preserved. So here I'm sampling, I'm getting a tibble of 10 rows, and then selecting out this column as a vector and passing it to the mean function. And so the petal width, so the average petal width in the data set is 1.08. No idea what unit. Okay, centimeters probably. Okay, and now the same code without the pipe would look like this. So I find this a lot easier to read than that. And the other thing is 2 parentheses, right? Parentheses are the bane of the existence for a programmer, right? Even though you get nice, you know, the editors now like how to line up your parentheses, and you can see where this one starts and that one ends and things like that. But getting parentheses in the right scope and it can really produce bugs that are very, very difficult to track down. So this actually also helps with bugs, because you don't have to nest these commands and parentheses. Okay, and now I have an exercise for you. And it's basically just do what I did, but you have to type it. Use the pipe to get the average miles per gallon in the empty cars data set. And I hope everybody remembered to make a copy when you open this. I did not. So I'm in tidy data, and I'm going to save this file. What did Josh have for mine, right? Underscore M-I-N-E. Oh. Oh, I should have made a copy instead of doing this, because now it, oh no, that's right.
I'm having a problem with my R Studio, like it's just frozen and I can't do anything in it, and even if I cancel my interactive session on the DCC, like all the names, cancel it, delete it, start a new one, it's still having a problem.
You didn't have a bill.
Well, it's like I pulled to make sure I have it up to date, and
Yeah.
it's not, it's up to date and there are no errors, but now it just won't let me do anything like that. So I'm sure it's my fault, user error.
I mean, you got it out of the closet.
Yeah, so,
Oh, I see, oh, it's,
and it's thinking,
if you stop,
it doesn't do anything. Maybe if I just sit here and wait. I don't know, so like logging into my CCC, like I can't click, they can't even like.
oh, yeah, it did take it out of anything.
I didn't know if I could do
And if
something from
you-
the command line on the DCC because I am a user, so I don't know.
No, because it's your container.
Oh, because it's in a container.
So, sorry, so did you kill the interactive session?
I tried that, right, again.
Then show, yeah, just do a long standing.
Yeah. I went over here.
Oh.
I don't wanna hold it.
Yeah, well, it takes a while, I guess, so, delete session.
Yeah, I did delete confirm. And then delete it.
Okay, and then you create another one? and
Yeah.
it's the same thing? What's this look? Watch. It's on the left hand side, okay.
Oh, there it is. Yeah. I think the problem is just my cooking. Might just have to wait and see.
I'm just trying to think, cause that, the delete should have.
Yeah, you would have.
Huh, all right, can you maybe, see what you can do, the work, you can send email support for the DCC? What do you mean? Cause it, well, first have a look and see if you can figure out what's going on. And then if not, you can send an email to the DCC, help people, and I don't know where that is, but you can, yeah.
Yeah, that's gonna bug me, why that's happening. Yeah. She deleted the session, that should have helped. Oh. Ching, try getting rid of .r data. What's that? Try getting rid, do you know the file .r data? All right, this is for everybody. Everybody should know this. Okay, by default, when you pull up an R session and you finish it, it creates a file in your home directory called .r data. This is a good thing to be talking about. Why is it not? Oh, right, I think I have mine. It might be set to not create one. But it's definitely, it should be here, my personal one. There we go, okay. So there's this file called .r data. And if you don't tell R not to do it, by default, it creates it. I think the containers are set up to not do that, but, so if you don't see it, then I'm wrong, then that was just a thought. But if you have this file, it saves everything that you did in the last session. And so it restores it. So when you come in, you're not starting from a blank slate. That can be it's actually really dangerous. So the best practice is to not do that because, yeah, especially like with code, you'll have like in your R session, you'll have defined a variable maybe in the global environment, right? And, but you don't have it in your script. But R thinks it knows about it already, you know, because it's in your R data. Then you give your script to somebody else and they're like, it doesn't run. I get this error. This variable is not found. And it's because R always assumed it was there because it was in your, it was saved from the session. So you really, really don't want to have this. .r history, you do want to have, that's the one that keeps your commands. And so you can up arrow like all day long, getting your previous commands. Okay. All right, that was sorry about that little break, but that was important, so I'm glad that came up. Okay, where am I now? Right, so I just had you do an exercise. I'm just going to show you where it is in the code. It is at line 42, and you can just put your code in there. What did I want from empty cars? I can do that. If most of you may have done it already. Trying to think what's an empty car. I said MPG. So if you don't know where the miles per gallon is in empty cars, just go into the console, empty cars, press a $sign, and you'll see all the column names. And sometimes you have to tab, sometimes it just does it automatically. But so here is, so miles per gallon is MPG. So that'll do it, and I executed it. Yeah, so you can see the mean is here. So the mean is 20 miles per gallon in empty cars. That's actually surprising to me. I don't know if they've updated empty cars, because empty cars I thought was like old cars, but just 20 miles per gallon on average is a lot for cars from like the, before 2000. Anyways. So I'm going to go back over to the HTML file so we can look at some diagrams here. So again, our goal today is to create tidy data sets. So what is a tidy data set? And roughly it is described as every column is a variable. Every row is an observation. So, if a patient comes into the office for like a visit, that's an observation. And every value has its own cell. So we're going to see some examples of where things are not that way, untidy data, and then we're going to tidy them. So the R for data science, that's a book that I highly recommend anybody who's going to do any kind of exploratory data analysis. This is the book for exploratory data analysis. So these examples are from that book, and they are built into R. So you don't have to define table 2 or load in a library. Oh, well, you do. You have the library tidyverse. Sorry, I lied. But it comes with tidyverse. So once you have that in, everybody knows, R knows what table 2 is, and table 2 looks like this. It is, I believe these are tuberculosis. So in a particular country in the years 1999 and 2000, and there are, so here is Afghanistan 1999, the cases count and the population count. So why is this not tidy? That is correct. There's an observation that goes across 2 rows. So Afghanistan 1999, cases and population should be just other columns. They shouldn't be spread across 2 rows. Table 3, anybody tell me what's wrong here? Exactly. The cells are not separated. So here, they're expressing this as a rate. It's cases over population with a slash put in between them. So in a tidy data set, every cell is 1 value, not 2 values here. Okay. Table 3. Oh, sorry, this is table 4A. Actually, I think. Oh, okay. So this is actually, so it's basically you have to consider both of these tables together, 4A and 4B. So in this case, I didn't tell you in a data frame, but this is the same information spread over 2 data frames. Okay, so that's where you have to get into joining data together. Okay, so I'm going to do some examples with a toy data set, and then I'm going to set you on to work on tidying up these tables I just showed you from R for data science. So this code just creates the data. Let's actually go back to the R file. You're going to want to walk through this, and you're going to want to have these things defined. Don't have to worry about those. Oh, you should actually, sorry, one thing we should do. Before we go down into the code, make sure you, oh yeah, this should not be here. You don't set working directory in an R notebook, but I'm gonna leave it there as commented out, but that's something you don't do. I learned that a little while after starting to use R Markdown notebooks. But anyway, just execute this because this is the setup chunk for the, and it loads tidyverse for us. Okay, and now I'm just going to go down to here, and this is now line 72, the chunk at line 72 in the code. And this is just, don't even, you can look at it and ask questions about it if you want, but this is not for teaching purposes, just for the purpose of creating a table. So if you have questions about it, you can ask me like on break or something. So here's a data frame. It's got 4 rows. It's got a patient ID, a description field that gives the sex and something that looks like age. And it has visit 1, some number, and visit 2, some number. I don't know what these could be. Pick a measurement. It's not blood pressure, obviously, but it's, I don't know, blood sugar count. So I have no idea. I don't know what would be a good medical, like observable that would be in those number ranges. But. Okay, so problem 1. Problem 1 is that each row has 2 observations, visit 1 and visit 2. Okay, so we want each row to have 1. So we want to actually make this longer, right? So so the concept, so in case you're not familiar, you can have data can be in a wide format or in a long format. Okay. Typically, especially for ggplot and stuff, they lean towards long because they want to have columns and then just, well, anyway, you'll see. So each row has 2 observations. So we're going to use this command called pivot longer. Pivot longer takes the columns, visit 1 and visit 2. So I've got these 2 columns, and what I want to do is I want to create a variable called visit and put the values in, which will be a categorical variable, which will label it as the visit 1 and visit 2. And then I put the names to visit, so that will create this column, and values to measurement. So we're going to get rid of visit 1 and visit 2, and we're going to create 2 columns. One of them is going to be telling us which visit the measurement is for, and the other is just going to be the measurement. And I'll show you how that looks. Okay. And so now this is in a long format. Okay. Any questions on that? Because these can be a little bit confusing if you haven't looked at them before. Has everyone seen pivot longer before? Some people know, some people not. Okay. My Zoom people. How's everything going on Zoom? I see there's something in the chat. Yeah. That's from today from Ching. Okay. So you should definitely, but people who are here are presumably not on Zoom. So let me tell you, there is So that's all about like filling in the repo and stuff. But we have to fill in the sign-in sheet. Chang, is this a sign-in sheet or is this a survey?
This is fine.
So it's instead of the paper that we passed around? Or is that only for?
That is only,
If only I ever read my email.
they sent me the sign sheet and also this is.
Okay, can you send that email to everyone in the class? You don't know how to do that. All right, I'll just figure out a way to, it's a tiny URL. All right, I'll do that later though. So, but we definitely have to take attendance and we definitely have to get your feedback on the survey. So those things are very important. All right, so any questions on pivot longer? Might have more when you try to do it. Okay. All right. Now, problem 2, there are 2 values in the cell's description, right? His description, it's got a sex and an age. Okay. So here, I'm going to start building things up with the pipe. Okay. So I filled the original data frame. I haven't written this over at all. Actually, I haven't saved, I'm not saving the output of this at all. I'm just printing it out. So starting with the original data frame, doing the pivot longer command, and then I'm going to pipe that into something called the separate command. So separate is a command that you give it the column name, that's description here, and you tell it what the separator is if you have one. It will default, I think it defaults to space, but it might even default just to like special like dashes and stuff too. And then into, and those are the columns. So this one's actually pretty straightforward. So it's just going to say, okay, I want to take description. I want to take, I've got this separator, which is a dash, and on one side I have sex, and on the other side I have age. And I want you to split that into those 2 columns, and it gets rid of the dash and makes this nice thing. Okay, but there's still a problem here because when R parsed the description column, it had a dash in it. So it automatically says, well, that's character. Because there's something in there that's not a number, so that's a character. So, if you might notice that measurement got cast as integer without us doing anything, because it was all numbers and an NA. But age is numeric, but it's defaulted to character because the separate command doesn't try to figure out what data types you have. You might be actually, I haven't checked this. It's possible that there's an argument you can pass to it to do that, but anyway, I just always do it this way. So I've got age as a character. So age is not numeric. Oh, and there's also a missing measurement, this NA here. So sometimes you want to keep NAs in your data set. Sometimes you just want to just not have them in there. So, because there really isn't any reason to keep this, because all it doesn't give us any new information, right? Because all we know is that they missed visit 1, and we know that if we don't see visit 1, so. Okay, so we're gonna, again, starting with the original data frame, pivot longer, separate that column into sex and age, and then to create this, to make this into an integer, I'm going to use the mutate command. So the mutate command does operations on columns, right? And you can even do operations across columns. So you can do something is the sum of the two columns, or you could do like a rate, right? You can say, maybe we wanted to know in the tuberculosis case, we wanted to know the cases over population rate. And you had cases and you had population, you can say, okay, take mutate rate equals cases divided by population. And that will create a new column in your data frame that will be rate, and it will be that function of the division of those 2. Here, I'm just using mutate to cast age as an integer. And I'm even replacing it, replacing the integer column, the age column, by naming it the same name. So I could, if I wanted to, I could create a new column here and do age_n for numeric. And then I would still have my age column and it'd be character. And then I would have a new numeric, a new integer column that would be age_n. So, but I don't want that because I don't need an extra column in there. So I'm overwriting it. And while I'm at it, I'm going to get rid of the string visit because I have a column named visit and then everything in there is visit 1, visit 2, visit 1, visit 2. So I'm just going to get rid of visit, that string in there. And that's this string remove. Again, same command, mutate. So this is all part of the same command. I'm overwriting age. I'm overwriting visit by removing the string. And then I'm also casting that as an integer, visit 1 or visit 2. And then I'm dropping NAs on the measurement column. So when I say drop NA of measurement, that is dropping any row, the whole row that has an NA in measurement. And now I'm actually saving it to data frame 1. To run that, and you can see data frame 1, and now it's really nice and tidy. Integers that are supposed to, columns that are supposed to be integers are integers. I got rid of that string. We have this nice measurement, and observations are across a row. All the things we want to have. Okay. Yeah.
Could you assign this to data frame 1 at the beginning of the line? Before that?
Thank you for calling that out. Yes, I could. And this is a matter of sort of style choice that people will do. So some people like to use the left assignment, right? And so they'll do DF like that instead of having this right arrow assignment. I really like, this is the reason this is my justification for using arrows instead of equal signs and R. Because with the pipe, it keeps everything going along in that direction, right? Left to right, left to right, left to right. And so for me, I feel like it's really like that's just as smooth. It should, okay, I'm gonna do all of these things and then assign it. But yeah, a lot of people do the opposite. They do a left assignment. It's a matter of taste. Just be consistent. Okay. Okay. So I want to join in another data frame. So I'm going to create another data frame that's going to have the patient IDs, but then it's also going to have names. So basically demographic data for the more demographic data. So creating the tibble, let me just do that. Execute it and show you names. So here's what the tibble looks like. Okay. So first and last names. And then I want to join, I'm going to do different joins. Okay. Actually, maybe I should go back to the HTML because it's probably easier to say. Let's do that. Oops. Choose the wrong window. There we go. Okay. So here's another data frame. And there are different ways to join. So there's inner join, left join, right join, and full join. Probably an outer too, but wouldn't know what it does. So, but inner join, so what you see here is that there are 6 patient IDs here in this data frame. But in our old data frame, there are 7, right? So an inner join on patient ID, so we're going to match these data frames up by patient ID, and inner join says, I only want the rows that match, that have matches. So if I don't have a patient ID 7 in either, like a match in either, then I will get I'll throw it away. So I only get 1, 3, 4, and 5 in here. We're also using the old data frame, but that's okay. And then a left join. So if I do a left join by patient ID, I actually get the same thing because it's missing, the missing value was in the right. But what it does, what left join does is it says keep everything from the left, and if there's nothing on the right, it'll put an NA in. But if there's nothing on the right, things that are on the right that aren't in the left, they just go away. Make sense? It just really, all it is basically it's going to join on some key, and which join you do is going to depend on what you want to drop. So inner join, left join, right join does the opposite. So here you can see the difference between the left join and the right join, because in the left join, I just have these 4 columns because I only have 1, 3, 4, and 5 data frame in the left. But when I do a right join, I have 1, 2, 3, 4, 5, 6. And so what it does is it keeps everything and then just puts in NAs for the fields that didn't match from the other data frame. Okay, and then, and a full join looks a lot like this one because I should really work this example a little bit better because it's, and yeah, so you can see the difference between these two, but a full join keeps everything. So if I had a patient ID 8 in the left one, I'd see that too. And then I have extras in the right, I see all of them. So full join for me, like it depends on what you're doing, but usually when I'm doing these things, especially because you'll do it and explore, you're going to look at things before you want, like have a full pipeline. I will do a full join first so that I can see what's going on with my data, and then make it decide, and then maybe decide whether it makes sense to do a left or a right or whatever. Okay. All right, and now we're up to your exercises. Yay! I'm asking you to do basically tidy up these other data frames. Let's go back to the code and get to the exercises. Exercise are at line 153, basically at the bottom of the file. Oh, I didn't tell you which tables to use for that. That's dumb. I have to just remind myself, and then, I mean, you could look at it too, but that would be helpful. There were answers in here, and I took them out, but it looks like I took out a little bit too much information out of this cell because I think this is probably table 2, table 3, and then 4A and 4B. But let me just verify that. Look at this. Okay, so table 2, type, yeah. Yeah, it's table 2, table 3, and then 4 and 4A. So. So this is a little bit of a trick. I said pivot, and I taught you pivot longer. But there's another command called pivot wider. So for this, you're taking one column and you're making it into 2 columns. So that's pivot wider. And I strongly suggest you use tab completion, or even actually, so when I just did this, So when you first type the function, it shows you, all of the different, things that you can pass to it. So just think about, so I want you, so you guys are a little bit advanced, so you can think about this. Think about how you would, specify a pivot wider versus a pivot longer.
The, second exercise, then to be.
Yes. Yeah, so table 4A and table 4B, it doesn't really make sense to just join them, because if you see what it is table 4A is the cases, 1999 and 2000, and table 4B is the population numbers. So I think what you'd want to do is first pivot longer, so that you have 1999 and 2000 in a year field, and then yeah, and then you have just a cases column, and the same thing here with population. You know what I'm saying? I'll do it, and you can think about it, and I'll do it and show you how. So.
So is there a difference between like you know, what I mean, 'cause it's the same exact years, and you don't know what year it is.
Yeah, we only know it because we've already seen all the other tables, right?
Oh,
But so the other table, it's cases and population. So table 4A are the cases numbers, table 4B are the population numbers. And what I'm saying is what you really want to do first is pivot both tables longer, so that you have a year column, and then you have cases for one and population for the other. Anybody need more time? I'm looking for hands or whatever from, or either hands or chat from the Zoom people. Okay, cool. So, so for table 2, it's just pivot wider, and then instead of names to, you have names from. So we take the names from type, and that's cases and population. It's the values. So what R is going to do is it's going to say, okay, I have this column. It has some string in it, like, and hopefully that it's really a categorical variable, right? So cases and population, this is, okay, I've got two different names in there. So I'm going to need 2 different columns. One is going to be cases, one is going to be population. And then values are from the count, field. And I can go back to the HTML just to show you what that looks like. Yeah, so you had cases and population in here, and you have the count for each cases and population. So I'm gonna, so pivot wider to make so that I don't have the cases and population, so the observations spread over two rows. And so this is the data it's gonna take, and it's gonna create columns. So I'm gonna have a column called cases. The first number is going to be 745. The next one is going to be 2666, and so on. And I'll show you how that looks again. Okay, so it's just pivot wider, take the names from type, and take the values from count. Make sense? Okay. Table 3, we had that problem where you had cases and population in a column called rate, and it needed to be split. I'll show it to you again, just so you can remember here. So table 3 looks like this. So you've got a country, a year, and a rate. But it's the cases divided with a slash and then a population. Go. So for that, you just separate the column rate into cases and population using the separator slash. No, I'm not being picky here. I should be. Almost certainly what's going to happen is that these types are going to be character. So you would also want to transform them into integers or numerics at some point, but I'm not doing that here. Is that clear? Some rate is clear. And then for 4A and 4B, again, they're two. It's what you have. You have observations spread across 2 data frames, but you also have the untidiness of having the observations spread across. The columns 1999 and 2000. So each column is not an observation. It's it's spread. It's you have 2 observations in one row, right? 1999 and 2000. So we want to make that longer. So go back to the pivot longer command. You have to tell it what columns you wanted to deal with, 1999 and 2000. Names to year and values to cases. And that gives you a table for A that looks like, I don't know. Why did it not print anything for me? Okay, let me bring that down into the console, maybe. I don't know where it's printing it, but it's not showing it to me. Anyway, you can see the full output. I'll just run the whole thing. So what I'm doing is I'm doing a pivot longer, exactly the same for table 4A and 4B, except 4B, it's the values population, and then 4A, it's cases. And then I do the full join on the 2 tables. And notice that I did not specify the keys. This is probably a little bit dangerous, but I'm doing it anyway. So probably it's better practice to specify the columns. But then again, the column names that you want it to key off of, because what it's going to do is it's not just going to go off of country, but it's also going to go off of the year column. So I might want to be explicit and say that I wanted to take year first, country first, and then year. But it could be that maybe there's another column added at some point, and maybe I want this to just join off of everything that's got the right same names, because that's the default. Essentially, that's what I'm trying to say. It defaults to all the columns that have the same names. Okay, so run the whole thing, and we finally get this. This is our tidy data frame.
So I added by country to the full join.
Uh-huh.
Now I've got,
Now it's going to be funky because you've specified, and it's probably not going to take the year into account.
right,
Because you're saying do it by country, and you're not also specifying year. So did it give you, what did it do?
well, hold on, we're asking, for each year I have 2 per country.
Yes.
It repeats on case, okay.
Yes.
How would you make sure it doesn't going by some other?
Oh, so if you wanted it, so you should do country and year.
Okay, so you can full join by country, comma, year.
Yes.
Okay.
Yes, but you probably, I think the syntax is probably going to be like a C command concatenate, and you have to put country and year in there, and you probably have to do it in quotes. There's a lot of there are a lot of little things in Tidyverse that are slightly annoying, and one of them is that sometimes you have to use quotes on a column name, and sometimes you don't, and it's a whole there's a whole thing about when you can do it and when you can't. And usually just when I see something, when I get a weird error and I haven't put quotes, then I put quotes. And I think quotes always works. Okay. Any more questions?
If you join by country and year, take each country in your pair as the anchor thing, match.
Yes.
Right, okay, yeah, okay.
Exactly. And if you don't specify it, it's just going to say every column name that matches. I'm going to match that up. Okay. All right. Well, that was tidy data. I actually have to haven't committed the other file to the repo. I didn't realize that I hadn't done that until about 15 minutes before I was supposed to be here. So I need to do that, and so I think now is a good time for a break, and then we'll do dplyr.
Oh, that's really. Let's do a 15 minutes. I have. That would be.
Yeah, hold on one second. Yeah, so the link is not. Oh, okay, I just have to find that email, so yeah, when did that get sent? Was it from Kelly? No, it's from Richard. But it was a while back, right? This is for the survey.
Yes.
Okay, and where's the, and the entire URL is the sign-in sheet. Okay. So much for me. Yeah. Okay, cool. I'll start with that when I. The in-person. I'll put the email up on my screen or something, I guess. Yeah, that's fine. I mean, because there's also like an email list for the course, but I don't remember what it is. Kelly sends things out to the participants, and we're not always CC'd on them, I think, so, yeah.
And like had the same directory name. It's still the same problem. My husband, they told me, put it in a directory with a different name. So it was like weird, even the meeting, if I went, she just went in the directory, I go like, repository now, still has the same problem. I don't know. I don't know if there is another solution to that. Yeah.
Not what I did before. Wait, where is this now?
Oh, okay, yeah.
Hey, looks like there's one person. Was that all your stuff? And I'm sorry, my point is, what?
This is all mine.
Oh, good, okay, I thought there was still one person missing then. All right, very good. Okay, so, oh, somebody's asking on chat, can you add the link for attendance in the chat? But I think it's in there already. Yeah, so for people on Zoom, the link for attendance should be on chat. But I'm also, for you guys here, I want you to see, so here is a sign-in sheet. Let me make it bigger. There's a tiny URL for it. Yeah, I really don't know what the best way to do this is, but it was in my email. So can you see it here? Tiny URL, and then it's YKZFSXY6. So if you can go there and sign in to let us know that you're there, you're here. And then if you want to like copy this URL code now, this is for the survey at the end. So you shouldn't fill it out now, but maybe if you want to like open up a tab in your browser or something like that to get this. I hope you can scan it. Maybe I have to actually make it a little smaller. It's probably easier to scan that way. What did I just do? Okay, I just kind of, wow. I think I just kind of touched the cable here and the whole thing went out. I have to figure that out. Can you repeat your question?
Is there an option to evaluate that class? I didn't get the QR.
You know what? I don't know. So this is done by we have an education specialist who's also like helping us out, and she writes the surveys. So I don't know if they have to be sort of an immediate reaction or not, because I thought we could. I also said that, you know, we could probably just, you know, because we forgot. It was our fault. We just kept talking and talking, you know. Like, it was like after 4 and everybody had to go. So yeah, I'll ask about that, or you can email Kelly Suna if you want. Okay. All right. Did everyone get the URL? I'm sorry, for the survey and also sign in. So both of those things.
I didn't get the sign in.
Okay, so the sign in. Oh, right. The problem to fix here. Jim or Matt, are you back there? I didn't touch this.
I can, send you a link to the Saturday.
Thanks. All right, maybe he'll try it. Oh, somebody's coming. I don't know what I did. The whole thing went blank on me. Like, I feel like I kind of like maybe bumped into the cable here and it just. Maybe it's my USB.
Nothing ever changed?
That I know of.
Huh.
I know of.
Computer is this?
It is a Dell. I may also have to like set this thing. I'm not sure where it's at right now. Looks like USB-C. Sorry, guys. Oh, you got another one. Okay, I thought I was going to try mine. I also have to tell my computer to share the screen, and I never know like where the toggle is when I. There it is. Great. Thank you. All right, cool. All right, so everyone is signed in and knows and has a link to the survey at this point, I hope. Oh, right, because
I'm sorry, no, I'm just nearsighted.
No, it's fine. I'm totally nearsighted, so there it is.
I can put an X from everyone here on the Google Doc, right?
You could do that. That'd be great. That'd be so much easier than what I'm trying to do here. I believe that this will be the same every week. Like the baseball player. I like that.
I think people used to get the reference and now, like, not as many people remember it, he's tired.
Yeah.
I'm actually gonna. Thank you so much. I had to do a presentation right before this for my 12-to-1 too, and I was like, I don't know, my brain was like not working, I just kept having all these weird pauses.
It's kind of a normal, it's a normal day for me. Okay. Okay, all right, great. Okay, cool. So at the end of class, I really will try very hard to give you guys time to fill out the survey. So hopefully we'll stop at like 10:02 or 5:02, and yeah, it's a short survey, but okay. Yeah, that'd be good. All right, yeah, okay, cool. So I just uploaded a new file to the repo, and I don't even have it on my container, so we can all pull at the same time, and hopefully it's gonna work. So depending on where you are up here, you should click on the Git tab here, and then you need to just click right here on this down arrow. Okay, and I get a bunch of information telling me that there was an update and that it changed one file. Okay, everybody with me so far? Anybody getting any merge conflicts or anything like that? Okay, so there's a question in the chat about net IDs and passwords, and yeah, no, it should be, you should be going to the same place. Yeah, it should be the DCC on demand. You should be able to log in there. Ching, can you help this person? He's on Zoom. Cool. All right. Okay, cool. So hopefully everyone has pulled successfully from the repository. And then, I'm all the way in my home directory here now, so hold on. Okay, so hopefully you're here in this, or maybe you're actually in data science. So this is the HIV workshop directory under your home directory. And then I'm in data science. And then I'm in introduction. And then we're going to scroll down and there should be 03 dplyr.rmd if you pulled successfully. Okay. Anyone having merge conflicts or anyone not have that file in their file system at this point? Okay, I don't see it. Doesn't seem, nothing appears to be on fire, so I'll just go on. Okay, cool. So I'm going to click on that file, and I'm going to pull up this this notebook. And here is where we are going to talk about dplyr. And actually, maybe I should feel like it's better to look at the knitted document for most of this, and then when we're actually getting into nitty gritty into the code, then we can look at the. There we go. Yeah. Okay. So I have updated this since 2020. That's why. Okay. Should change that. Okay. So dplyr, as I said, so tidyr was the one where it's the package where you get everything tidy, and dplyr is the one where you can manipulate things. Most of the time, like if you're a stickler for things, like I'm not, you would load the package that you need, right? Not all is tidyverse. But there's a reason why you're able to say library tidyverse, and that's because most of us are just a little bit lazy. And knowing which command comes from which package is not something most of us want to have to deal with. So yeah, so you can just load tidyverse. That's what I do. And then and then you'll have access to dplyr. But for the purpose of these lectures, I have actually separated out two different packages so that you can have an idea. So the first command we're going to go over is called select, and that's it's just how you get columns. So like you had this maybe like data frame with who knows, like 350 columns, but you only want the ones that start with name, like or start with some letter or something, or contain a particular string or whatever. But or just certain ones. You want to pull out maybe 4 of them out of 350. So that's how you do it with select. And the nice thing about select, like I was saying before, the other ways to kind of get things out of data frames in R didn't always give you back a data frame. So, especially if you only took one column, yeah. So with select, you'll always get back a table. Okay, and this I am just showing you, so introducing you to the Star Wars data set in R. If you're not familiar, it's kind of fun. These are the first few. They've got Luke Skywalker. His height is 172 centimeters. He's not 172 inches. I don't know. I don't know what that means. His mass, hair color is blonde, skin color is fair, eyes are blue, birth year, and so on and so forth. But it's got, everybody's in there, I think. Well, not everybody, but most of the Star Wars characters are going to be in there. And the select command, so I have this table that has, so you can see it has, it says 6 by 14. So it's 6 rows because it's only the head. So that default is just showing me 6 rows. But then there are 14 columns in here, but I can get a smaller table if I just want to say name, birth year, and species. And note here in select, this is part of the tidy select syntax. You don't have to put the column names in quotes, and you don't have to put them into concatenate them with the C command. So that is something that I find, it's cool that you can do this in tidyverse, but it can mess you up in other places, because in other places you absolutely have to give a vector of strings for the column names, and you can't just, so you have to not only put them in quotes, but you also have to wrap them in a concatenate command. Is that, people are looking a little confused. I wish I had, there's a board over there, but it's too much trouble. So I'm just trying, I can't think of a specific example. That's probably part of the problem. But there are times in R when you want to specify, I think actually in the pivot command, when I want to specify columns, I'm pretty sure I can't just say, give them the column names. I have to wrap it into like a C concatenate, so C open parentheses, quote name, quote birth year, quote species. I'd have to do for some things, but in select, in dplyr, in most places you don't have to do that. Okay, so here, so here I'm just showing you the select command, the simple select command. In the next block here, I'm renaming a column using select. So instead of birth year, I want to change the name of that column to age. And so I can do that with select. And it's kind of a neat way to do it, because otherwise, there are many different ways of changing the name of the column, but this is probably one of the neatest ones. And by neat, I don't mean cool, I mean tidy. Okay, all right. And next one, so you can also use this minus syntax, which is kind of nice. So if you put a minus before a column name, it deletes that column. So in this command, I'm taking off name, birth year, and species, and keeping all the other columns. It's kind of nice. You can use helper commands. So there's starts with S. So I can say, okay, I want all the columns that start with S. And there are lots of applications for this. In the Star Wars data frame, it's kind of hokey, but there are places where you might want to say starts with date or ends with date, right? And you want to pull out the date columns from a data frame. So this is very, very useful helper functions here. And so, yeah, so only things that start with S. This, oh God, I hate this. This is something called a regular expression. It's a syntax for sort of matching values, matching string to match strings. And this one is saying, okay, I want strings that have any of these vowels in them, A, E, I, O, and U. And I honestly don't remember what the two comma means. So the thing is, regular expressions are very, very, very useful, but way beyond the scope of what we're going to do. Every time I have to use a regular expression, I have to go back to the Wikipedia page and read the whole thing again and remind myself how these things work. So they're just, most of the time when you do string matches, you're doing like a starts with, and you really just want to match those letters. But I just wanted to point out that you can use, there is a way to select using regular expressions. And if you're needing to do that, or for some sick reason wanting to do that, you can look it up. It's called regular expression. All right, so yes, so I can also, I guess I didn't, no, just calling select. All right, sorry. Okay, here, I'm here. In addition to select, I can, there's also a nice little command called arrange, and that sorts. So, and this is very, very useful. You can, so I'm selecting these three columns, and then I'm piping that to the arrange command and asking it to put it in order of age. And by default, it will give you ascending order. So we'll put the lowest first. And here you can see if you use this, if you, you can use the DESC command to arrange in descending order instead of ascending order. Worked here in Mass. I love this. Word. Okay. Leia was 19. In the first Star Wars movie, Leia was 19. That always kind of gets me.
How is C-3PO older than Darth Vader? Doesn't make any sense to me.
Well,
Anakin-
okay, I didn't actually know that Anakin built C-3PO.
Yeah, that's Phantom Menace.
Yeah.
Yeah.
But wow, yeah, okay, that's a great, okay. Maybe this data set needs some cleaning, or maybe, oh, I'll bet you anything. In the original series, they might have, the original like 3 movies, they might have not had that backstory. Because they were written after. Anyways, we should probably not get on a Star Wars side, but okay. Range age. Sorry, that's what I want to show you here. So you can select these guys. Oh wait, well, okay, I'm not sure what I was doing here. Yeah, I'm not sure why I have that extra line of code. It doesn't make any sense. But this does make sense. So I can arrange by, so here I'm taking the Star Wars data frame, selecting, renaming the column, birth year to age, and mass, and then arranging by age, and then within age, mass. So so that takes, say, yeah, so here you see Leia move down here is now here, right? And Luke, because Leia and Luke are twins, so they have the same age, but now because we're doing by mass in ascending order, Leia comes above Luke instead of the other way around. So you can nest your sorting. That's the point there. Another fun command is called top n. So you can take the highest so many numbers. So this is saying I want the top 3, like the oldest 3 characters in this data set, and that gives me Chewbacca, Jabba, and of course Yoda. Okay. All right. Now I have some exercises for you to do, and what I find really interesting. So last year, one of the TAs gave this lecture, and she used different answers than I did. So I'm going to show you, I think I'll show you hers, and we can work them through together. Yeah, so I mean, some of them are, just dumb, but then the way that she did some other things was very different from the way that I would do them. So here are the exercises, and let's go back to the code, and I'll find you the line number. Okay. Here we go. Okay, so they start on line 73. Oh, what, oh, right, that's, okay. So you can do, oh. Oh, because it's not, okay. It's diamonds anyway, so. Huh, that should work. I don't know why. Maybe diamonds is also tidy verse?
Oh, there we go, I found it.
Okay, you might, so probably a good idea, I didn't have you do this, to go to, the chunk, the first setup chunk at line 9 and run that, because, that loads tidyverse and we might not have it loaded. Oh, another thing, so that's one thing that you can do is just hit tab with $, but you can also do column names. So that's here, bottom of the screen. And it shows you what all the column names are. So if you're on Zoom, when you finish, it would be helpful to me if you just put up the, I guess, I don't know, the thumbs up icon or something. Are people still working on shopping or a little bit? Okay. Oh. Some kind of force field? What's that? I know it's back up, but it went off and I'm just trying to figure out, like, okay. Just gonna stay with more. Does anybody need more time, or can we move on? Okay, let me know if I'm giving you too much time. I don't want to do that, but I also don't want to rush people along either. Okay, so of course the first is just, select X, Y, Z. That's pretty straightforward, I think. Everything but price, you just use the minus sign syntax. The 5 most expensive diamonds. You can do that 2 ways. You can take the diamonds, you can sort it by descending order price, and then take the first 5 using head, or you can use top end, which probably does exactly that. So I think it's probably a wrapper that does that. And then there's another one, and this is one the TA put in, and I don't know, I did not know about slice max. So apparently you can do that. You can take out the maximum and then 5, and this presumably also a slice min. The 5 least expensive diamonds, and only the specified columns. So you can do the arrange by price in ascending order. Select starts with C, because I don't know if you noticed that all of these columns start with C, and then take the first 5, or you can do a slice min order by price. So there's a slice min with n equals 5, and then just select starts with C. You can also, of course, put all of the column names in there too. That's valid. And this is, this starts with, it's very useful, but it's also one of those things that's a little bit dangerous, especially if you only give it 1 character. So you really should know what your data frame looks like when you use it, so you don't inadvertently either leave off or or take either leave off a column or take more columns than you wanted. Yeah, I mean, because sometimes you see weird things. Sometimes the column should start with the word date, or end with the word date, but somebody decided to do DTE for date instead of, so yeah, just really know what your data looks like when you use this command. 10 most expensive diamonds with the largest carat size. You can do this, I don't know if that actually works. She's commented out. Let me see. So you can arrange by descending a price and descending carat, and then take the first 10. This is commented out, and I'm curious why. Okay, yeah, it doesn't like it. Huh. Okay, yeah, I don't know why that doesn't work, but it does not work. It's not a command that I am familiar with at all. I've never actually used it on my own for any reason. So, okay. Yep. Okay. So now we're on filter. I'm going to go back to my knitted output. So the 2 main verbs really in dplyr are select and filter, because that's how you pull out your columns and how you pull out your rows. So filter selects rows of data and selects this column. So I can get everybody whose age is greater than 100, and the way to do that is use filter birth year greater than 100, and then you'll get this data frame. And looks like there are only 5 characters who are over 100. Okay. I can combine, so any logical statement works in here. Any logical statement that looks at values in the columns works. So birth year greater than or equal to 600, and name or name is equal to Duco. That's an and. So the bar, vertical bar, is an or, and the ampersand is and. So birth year greater than or equal to 600, or your name is equal to Doku, and so I get Java, Yoda, and of course Duco. And this is just showing how you can, combine it with a select command. So just keep the pipe going. So I have filter, birth year greater than or equal to 600, or name equals Doku, and then select just the name, age, and home world. And also, so a comma means and. So you can use an ampersand for the logical and for filter, but you can also just list the logical by with a comma, and then it just combines them with and. So this syntax means birth year greater than 100 and sex equals male. And so you can see that here. Okay. So you can also, and so here, so like the starts with and whatever in select, there are also helper functions for filter. So string detect is one of the ones that I use a lot, and it just says take this column, home world, and something that has the letters IN in it, and then just select name and home world. And it turns out the only ones that have IN in them are, how do you say that? How do you say that? Tatooine?
Yes.
Okay, thank you. Tatooine. I haven't watched Star Wars in a while. So, yeah, so now I've just got some more exercises for you, which, as I think the best thing for you to do is just do it. So find all diamonds whose cut is ideal, find all diamonds with a carat greater than 2, find all diamonds with carat greater than 2 and cut premium or ideal, and find all diamonds with cut better than fair, and use filter with string detect to select all types. Whose cut is good or very good. Anybody need more time? A little bit? Okay. Yeah, please don't be afraid to say it. I'm really okay. Okay, I'm gonna make an executive decision to go on now. Okay, so very, very quickly, let me go over these answers. Okay. There is a little bit of a trick, so maybe that's where people were stuck. So the first few are pretty straightforward. So you want only the ideal cut, you just say cut, filter cut equal ideal. Again, in case you haven't noticed, the comparison operator in R is the double equal sign. It is in most languages because the equal sign is often also used as an assignment operator. Yeah, if you do something like this, I don't know what it does in R. Probably, I don't know if it gives you an error or not, but like in a language like C, if you do like cut with equal something, it will just evaluate true every time. It'll be like, oh, you want here's an assignment, okay. What does the assignment return? Well, it returns 0, 1, successful or unsuccessful, and the assignment is successful, and so it evaluates the true every single time. So, yeah, fun stuff. This language did they went on again. I'm not doing anything. Okay. All right, so then for carats greater than 2, you just put carat greater than 2 into filter. Carat greater than 2 and cut equal ideal or premium, then you just have to keep building your logical statements up together. So carat greater than 2, the comma again is evaluated as an and statement. And then for the cut, you just have this in parentheses now because you want the whole thing to be the or, and if you don't do that, it will give you your syntax error actually at this point. Cut equal ideal and cut equal premium, or cut equal premium. And these are equivalent. So you can also, yeah. And actually, this is an operator I use a lot in. So you're just saying you want this variable. You want to take every row where this variable is either ideal or premium, but the thing is that this generalizes. So you can put a list of however long you want of things that you want this thing to be in. So, and it's definitely something I've used a lot. And then for this last one, for this one, ideal or premium, wait, no, that's not right. What's a cut not equal to fair? No, that's, okay, you don't have this yet anyway, so that's not true. That was probably for something else. Right, that's the last one. Yeah, it's just in the wrong place.
It's fine.
Right, okay. Oh, okay, right. I just don't have it. Okay. Better than fair, right? Right. Oh no. There we go. Okay, and the way that so this is equivalent. No, so this is a short way to do it because, and I want to show you this. This is a categorical variable in this data frame, right? What you need to know is what are all the values of this categorical variable, right? So that you can make a decision on how you want to code this. And so this isn't in the notes, but I'm just adding it on here. I can use a verb called distinct. So I want distinct of cut. And this is also very useful. So, excuse me. So this is an ordinal variable, and you can see that it's ideal, premium, good, very good, and fair. So fair is the so the only thing. So fair is the last one it can be. So all the diamonds better than fair. You just say, well, just not fair, because that's the lowest you can go. And for grapple. So she added a few things in here, the TA. So so filtering for cuts that contain good, goo for very good or good. I think I had good in here, and I would keep it because you should probably put as many like things that match in there as possible, because who knows, maybe there's a GUI in there somewhere. I don't know, but I would definitely look for good. Okay, and this so string detect is the filter way of pulling out something that is a string contains, essentially. I don't know, it's like, there's a contains that works with select. It's a little bit confusing, because there's a verb or function called contains that works with select, but it doesn't, so selecting a column names. But for filter, you have to use string detect, not string contains, and it's just strange. But it is what it is. That is the verb you use. And then there's this, you can use grepl. So grep, if you're familiar with Unix at all, grep is something that you use in the Unix shell scripts to find all files that contain something. So if I wanted to find, I have all like text files on in one directory that had the string, I don't know, hello. I can say grep hello and then star or whatever files I wanted to look at. And it will show me all the instances of hello in all of the files. So that's what grep does in Unix. And apparently there's a grepl command. Actually, where is that? I'm just curious what library it is in. Oh, it's from base. No? Did I say grepl? It's base. Oh, okay. I do get that feeling that so this is a staff biostatistician who is a TA, and I do get the feeling that they use a lot more in base R than I ever do. Like, I just work mostly in tidyverse, and I don't worry about these other things. But I guess maybe, I don't know, maybe when they were learning, maybe tidyverse wasn't fully developed, and they had to learn all these other things. But that's cool. Okay, so you can use grep, string detect, and oh, okay, yeah. So this goes back to regular expressions. So instead of this isn't just a match for the string GOO. It starts with good. Okay, so actually this wouldn't actually answer the question, because this would only give us good. It wouldn't give us good and very good. But the caret means the beginning of the line in regular expression land, but we don't want to go. But some of these are that's useful, and that's not as cryptic as some of the other stuff. Okay. All right, so that was that exercise. I'm going to go back to my HTML again, and we'll talk about the next two verbs called mutate and transmutate. So we saw mutate already. It operates across columns. So basically, it's a way that you can apply some sort of function of, values in columns and create a new column that has that result in it. So I'm just looking at the beginning here, and then selecting name, age, height, and mass, and then computing a BMI, two columns, a BMI, which is the computation for BMI, so that's the function of mass and height, and then another column that's a yes or no for obese, which is a BMI greater than 30, which is antiquated, of course, everybody knows that, but it's an easy example to pull out of this. So R2G2, chonky. So this is, so you can see that we created two new columns and that they were functions of the other columns. The difference between mutate and transmutate is simply what is returned in terms of what they're keeping. So if you mutate a data frame, you return the whole data frame with those columns appended to the end, the new columns. If you transmutate, you only get the result. So here, it throws away all the other stuff and only gives you the things that you calculated. Okay. I've never used transmutate, and yeah, it's never come up as a thing, but there must be a need for it in some applications because it wouldn't be in there otherwise. Okay. This is a little bit funky, but it's for people who are maybe a little bit more. This is also base R. I think she rewrote this on me as well. So So it transmutes, so we're gonna throw everything away, except the storage data frame, I'm gonna throw everything away, except for, wait, what? Hold on a second. Oh, right, okay. So we're gonna throw everything away except for the things that we were mutating, right? And here we are mutating everything, so this where is character across. So it's saying everybody who is a character, I'm gonna change, use this function to change to uppercase. It's a little complicated, but yeah. And this, by the way, is something called, and we don't really cover this, but they do come up quite a bit when you're a little bit more advanced. This is called an anonymous function. So this command takes, you know, a location of columns, right? And then it applies a function to them. And so you might put a function name in here, like obviously the BMI greater than 30, or you might actually, you know, create your own function. So this is like your own function. I think if you do it without, yeah, this is because we wanted to go across all these columns. If we didn't, then we could probably just use string to upper on one column, but going over all of them makes this necessary. And so you can see everything gets turned to uppercase. All right, just looking at the data frame again. And yeah, this is just showing that you can transmute across, and you can just state what columns you want rather than using that. This is basically a selector function, is character. So it's going to go to all of the columns and say, are you a character column? Okay, come. Are you not? Okay, you know, go. So here you can just specify, instead of using that syntax, you can just specify birth year, height, and mass. Those are the ones we want, and then apply a function to those. And the function is x+1, which is nonsensical, but just to illustrate the fact that you're applying this function across these guys. Okay. All right. Okay, and just one exercise for this bit. Add a new column to the diamonds data frame called class that is 1 if the cut is ideal or premium, and the caret is larger than 2, and 0 if not. So it's an indicator variable. Oh, yeah. You might want to look up a command called if else. How are things? Do you need more time? Probably just go over it if that's all right. Yeah, cool. All right. So, yeah, there was a little bit of a trick here because, well, I mean, there are other ways to do this. You can also like write a function like we did with the other, like the couple of transmute things, that returns, you can write a function that does what this does, essentially. So, I'm gonna use mutate because we want the whole data frame back. We just want to add the column. And then class is going to be the column that is, so this if else statement has a logical statement here, and that's cut is equal to ideal or cut is equal to premium, and caret is greater than 2. That's a logical statement. It's going to be evaluated whether it's true or false. And then if it's true, it will return 1. And if it's false, it returns 0. It's an extremely useful function. I use it all the time. And that will actually make sure that this still works, because sometimes it's broken, but okay, there we go. Yeah, and so there's the class variable. And you can't see any ones because I think, okay, I have to check that and make sure that that is actually still working, because I kind of remember that there might have been a change in the functionality of mutate that might make this not work anymore. But the other way to do it actually is is to just use base R, and you can just do this. I'll show you. This is old school. So if I diamonds dollar class, this is actually creating a new column. So if the column doesn't exist, it creates it new. Like if you use a $ and an assignment, or it will overwrite the column if it does exist. So I'm just I'm saying create this column, diamonds dollar class. The difference is here, I haven't changed this. I haven't changed the data frame diamonds at all. When I do this, I'm actually adding a new column to the data frame. Oh. Huh. Okay, never mind. That doesn't work. I think it was the other one. It's fine. I'm not thinking this through, probably. I shouldn't do these things like on the fly. Sometimes they work. Okay. Yeah.
Right, can you say again what the 1 and the 0 do at the end?
Yeah, so it's from the if else statement, it looks at this logical thing, right? And so it looks and says, okay, and it does this like across the data frame, right? It says, for each row, is the cut ideal or premium and caret greater than 2? And if that is true, it puts a 1. Otherwise, it's a 0. So you get a column of 1s and 0s. That should be 1 when the thing is
So
satisfied.
there, for example, you put 0, 1, it would be 0 if it was true?
That's correct.
Okay.
Yes.
Thank you.
You're welcome. Okay. All right, so that was just one exercise. Let's go back over here. So these I use all the time. This idiom, group by and summarize. So what it does, so summarize just takes, summarize is a variable. So if I took a Star Wars and I said, summarize giving me the average mass. So average mass is equal to mean of mass. Always have to do NA.rm equals true when I use mean, unless I know that there are no NAs in there, because if I don't, it will return an NA. And then median age is median birth year. Again, NARM equals true. And then that returns to me a tibble, because we are still in, even though there's only one row, it's still a tibble. And it gives me the average mass and the median age over the entire data set. Okay. I can also use this across and where is numeric thing to summarize over a bunch of columns. So here I can take the mean of every numeric field, every numeric column in the data frame. So it does that. Sorry. Oh, okay. All right, so this is doing, yeah, this is basically defining the function, showing you that you can use your own whatever function you want if you want to write your own, but really what it wants as an argument is a function. So you can just say summarize across where is numeric, and then say I want the function that I want to apply with summarize is mean. That's the summary function I want, and I'm passing the argument na.rm equal true to mean. Okay. So these are basically two different ways to do exactly the same thing. Okay. Like this. Oh, okay, yeah. So again, this is the TA who's doing the stuff with the across, and it's deprecated. People know what deprecated means? This is fun. When you really start like programming a lot and for over years, they changed it, and as things get changed, so it's actually the ... argument. Okay, I don't want to get into what that means, but there's part of the syntax that we're using that they're not going to support in future versions. So it's deprecated for now, but at some point it's going to go away. So this is a warning. It's like at some point your code's going to break. Warning. And if you are going to use this code, if you think you're going to use this code in the future, you should definitely fix it because it will go away and then your code will break. Okay. So again, this is the same thing I did before, except I'm passing it a list of functions. So I'm telling it I want to summarize, but I want mean and median. And so I pass it as a mean and median as a list, and then na.rm equals true goes to both of those functions. And so I end up with this 1/6 tibble that has all of the numeric fields and takes the mean and the median of those. Okay. Also, I didn't. There's definitely a naming convention that I could have used instead of getting about height 1, height 2, mass 1, mass 2. Could rename them all so that it's like average height, median height, etc. Okay. This is just the average mass. Oh, no, sorry. Here we are. Finally, the real point of this, right? Group by. So summarize, sure, you can apply a summary function, across all the numeric columns or whatever. But group by as group by and summarize as an idiom together are really, really powerful. So when I say group by homeworld, it's like R kind of in the background, like decides, how many homeworlds there are and who belongs to what. And then I can summarize average mass, and I give it the mean function. And then it will give me the average for each homeland. So, homeworld. So it sort of makes a note of, the different homeworlds, and then it applies the function not across the entire data frame, but individually to each homeworld. And this is a function I'm using daily, multiple times. So this is really powerful. And this looks like it doesn't actually do anything, so I don't know why it's here. Yeah. Because we didn't have, I think at some point there might have been an NA in the home world of this data set, but it looks like it's been corrected, I'm guessing, because this is filtering out is.NA, but there are no NAs. So my guess is that when I wrote this, there was an NA in homeworld in one of the rows, and now somebody went and said, "Hey, that's supposed to be that one." Okay. Okay, cool. So now you can do the exercises using using the summaries and group by and summarize. And there's just 2 of them, and that's great because it is 20 to 4. So we can work on this for like 10 minutes or so, and then we could go to the survey. Okay. Yeah, so for the count, you have to know what the count function is in R, and it's actually N. It's just N function.
the average?
Oh, it's a really good question.
The mean of everything, right?
I think I'm gonna mean of all the, merit fields.
Oh, okay.
Yeah.
I have to see what I written, let's see. Yeah. Okay, I should probably wrap this up so that we can do the survey, and then if people want to work some more, I can hang out. So let me get to the answers here. Oh, these are the answers. I'm here. Okay. So group the diamonds by cut and find the mean in each category. So yeah, so I should probably clarify that I want the mean wherever for all numeric fields, which is what we have been doing in the examples as well. So so you type to group by and cut is the column you want to group by, and then summarize, and you'd use this idiom across where is numeric. So that's just saying which I want to go across all of the columns that are numeric, and I apply the function mean, and that will do that. And then these are equivalent. So to count the number of diamonds for each color, you group by color first, and then you summarize using the count command. So, and again, this isn't something I use all the time. This would be something like where you're trying to build a demographic table, for example, like group by age or something like that. If there are age categories, and then you count group by sex or age or what should we call it? Any other like sort of categorical demographics you can think of. And then you can also just pass it to count. So you don't have to, you don't actually have to do the group by and summarize for this. And what this tells you is if there's something like this, it tells you that people are using this all the time. If they have developed a new, like a sort of a shorthand to this code. So instead of group by and summarize, you could just say count. But it does exactly the same thing. It's going to group by count, and then it's going to it's going to apply the end function to it.
I have a question on that. Normally, summarize uses like a function, but then you have summarize using, I guess, defining a function.
Sorry, that is a function.
Right, but n equals n parentheses.
So I'm naming the column.
Oh, you're making a new column.
I'm making a column because I'm going to get a whole new data frame, right? It's going to be the color, right? And then it's going to have another column. It's going to be the count. So I'm naming the count column n. Yeah. Sorry, I didn't point that out. I mean, I could also call it count, but okay, I should execute this. And that's what things look like. That's what the count looks like. No, okay, so I did it twice. Okay, and here's the other table with all the means for everything, all the numerical variables.
Now, in the shortcut, if you wanted to name the column something else, could you just do that internally, or would you have to?
In the shortcut, it might be n. It might be. You might just. Yeah. Hold on a second. Let me.
But I was just thinking if you wanted to name.
Yes.
Yes. Would you do that just within the shortcut, or would you just have to type another?
I am gonna. Let me see. Okay. Didn't change anything. So it didn't like. Yeah, that doesn't do anything different. Hold on, let me do one more thing. So if you're in a function and you want to know what the arguments are without going into the help screen, you could do a comma like in there, or just like without anything in it, you can just like tab. And I had colors there, sorry. The color, and then if I want to see more, I put a comma and hit tab again. Name. Let's see. There you go. Ooh. All right, cool. All right, it's 3 minutes before, but so everybody, please fill out the survey and make sure that you've signed in. And I am here for questions, and this Ching can also answer questions over Zoom. So. It's freezing cold in here, isn't it? Or am I the only one freezing? It's cool. Okay. See you next week.
Oh, okay. I've been getting right here.
I have to ask if I can get a parking pass, because I don't have a permit for this either.
You don't have a parking? Oh, my normal parking is like right here.
Oh, yeah, it's expensive.
Oh, yeah, well, I live in Seaway, so I am not gonna ride a bike here.
Yeah, that's,
40 miles.
no, I live less than 3 miles from here, so I have,
30 miles away, so.
yeah, I have no excuse to not take the car, and I end up doing it anyway, but.
Hey,
Thank you.
when I was in college,